Hi guys, now that we have graphed sine, cosine, and tangent, we are going to graph the reciprocal functions. Sine's reciprocal function is cosecant. So in order to graph cosecant, we're going to graph sine first. We know that sine starts at the origin, and every 90 degrees we have a new point. So we have a pattern, and we can go backwards with that pattern. Above, on. We're going to dash this in. This is sine. This is not really what we're after. We're after cosecant, but we're going to dash it in. And where sine has a y value of 0, cosecant has a y value that is undefined because 0 over 1's reciprocal is 1 over 0, which is undefined. So long story short, anywhere we have x-intercepts, where our graph crosses the x-axis, we will have vertical asymptotes when we graph cosecant. So let me put these vertical asymptotes in quickly, and we'll move on. Okay, speaking of reciprocal, since cosecant is sine's reciprocal, where sine makes, I want to say parabola, where sine makes a parabola down, cosecant will use the same vertex, but it will make a parabola up. Use the same vertex, and if it's a parabola up, cosecant will be a parabola down. So parabola down, cosecant will be a parabola up, and a parabola up, cosecant will have a parabola down. Now, one full cycle is a parabola up and a parabola down. Just like you're seeing one full cycle of sine, one full cycle of sine would be one, I call it one mountain and one valley. So one full cycle of cosecant is one parabola up and one parabola down. Cosecant does not have amplitude, so we're just going to say not applicable, and that's because it goes up forever and down forever. It doesn't have a set number above or below the midline. The period, so how many radians did it take to see one parabola up and one parabola down? It took 2 pi. You find the period the same way we always do. 2 pi divided by b, and b is in the same place. Okay, the phase shift, this one didn't have any phase shift, nor did it have a vertical shift, so we'll just say NA. The domain is kind of tricky. The domain is all reals except where we have those vertical asymptotes. So where do we have the vertical asymptotes? I usually start at any one of them. I usually start at, like that one's x equals 0. So x cannot equal 0, or how far are my vertical asymptotes apart? They're apart pi k. So my domain is all reals except x cannot equal 0 plus pi k. And the range is negative infinity up to -1 with a bracket, union, bracket, +1 to positive infinity. It does have symmetry. It has origin symmetry. And our midline or center line is y equals 0. Moving on with number 2, y equals secant x. Secant is the reciprocal of cosine, so I went ahead and I graphed cosine. Same thing where cosine intersects the x-axis, secant is undefined because where cosine has a y value of 0, if you flip 0 over, that would be undefined. 0 over 1, and then 1 over 0. 1 over 0 is undefined. Okay, so we do have vertical asymptotes again, and same thing. This is like the vertex. We get a little half parabola there, a parabola down, where we use that one point as a vertex, parabola up, parabola down, and again, we have kind of a half parabola that we're seeing. All right, again, there is no amplitude because amplitude means you're above the midline or below the midline a certain number, and secant and cosecant go forever above the midline and forever below. So there is no amplitude. The period, again, to see one cycle, it's the same as one cycle of cosine. One cycle of cosine is right there. That is 2 pi. You find the period the same way we've always found the period. The formula period equals 2 pi divided by b. The phase shift, this is the parent function. It did not have a phase shift, nor did it have a vertical shift. The domain and the range. The domain is a little tricky again. We start out saying all reals except x cannot equal. Now, where is my first vertical asymptote? Pi over 2 plus, and how far are they apart? They're apart by pi, k. And that's how we write the domain. The range is negative infinity up to -1, bracket, union, bracket, +1 to +infinity, parenthesis. And symmetry, this has y-axis symmetry. Now this is the parent function. Not all secant functions have y-axis symmetry. And the center line again, sorry about that, y equals 0, the x-axis. And last we have the parent function y equals cotangent x. So I'm not going to graph tangent, but we are going to talk about it a little bit. We're going to recall that tangent normally has a dot at the origin, kind of like sine. But in this case, cotangent is the reciprocal of tangent. So cotangent will have a vertical asymptote instead of a dot. So long story short, where tangent has a dot, cotangent has a vertical asymptote. And where tangent had a vertical asymptote, cotangent would have a dot. So we alternate vertical asymptote, and then a dot, and then a vertical asymptote, and a dot, vertical asymptote, x-intercept, vertical asymptote. And one other difference is cotangent falls. It starts high and it falls as the graph moves left to right. And that is cotangent. Cotangent does not have amplitude because it goes up and down forever. The period to see one cycle is 180, so pi. The phase shift, this one didn't have one, nor did it have a vertical shift. The domain, again, is a little tricky. We say all reals except where we have those vertical asymptotes. So where do we? So x cannot equal 0. That's where a vertical asymptote is, at 0, plus, and then how far apart are they? They're pi k apart. The range is negative to positive infinity. This does not have any symmetry. And our midline is y equals 0 again. All right, that concludes the parent functions. I'm going to do a separate video, and I'll do some of these others in the separate video. Have a good day.